Hello guys, today I'll be starting my first video series on my scheme of work from trigonometry. Um, I'm really sorry about the camera quality, but as time goes on, it's going to improve. Okay, now let's get straight to what I came here to do. What is trigonometry? Trigonometry is a subset or a branch of mathematics that deals with references. It deals with references and locations and positions with respect to something else. It also tells us about how what the location. It's not just about location because coordinate geometry specifically talks about location, but it tells us how we see things with respect to an object, not an objective, but how we. It's not an objective, but like an agreed set of axes. Like if you have we know the x is this way and the y is this way, and then let's say we have some particle that's not the x and y. So we try to describe what is the position of that particle with respect to the already defined axes that we have in mathematics. So without further ado, let's get into work. Okay. Now, we have 6 functions in trigonometry. The first 3 functions are the normal ones we use, while the other ones are the inverses. So we have sine, cosine, tangent. The other 3, because we have 6, are derivative of the first 3. So there's the inverse of sine is cosecant. For cosine is secant. Y for tan is cotangent. So write them as cosec, sec, and cotangent. Now, let's talk about angles and the domains of the angles, and also how these functions, how they behave when they are found in different sections of the plane in which we use to map out angles. Now, this is the plane we use, the XY plane. And we use the XY plane. Now, one thing we need to know is the angle between this and this is 90, this and this 90, this. So there's a theory, not a theory, it's what we call them theorems. A theorem that tells us that opposite angles are equal. So if these two are 90, 90, therefore these two are 90, 90 as well. It's common sense, right? So we have a total of 90 times 4, that's 9 times 4, that's 36. So that's 360 degrees. I think we all know all of this actually. Okay, let's go straight in. In the first quadrant, which is the first segment of this plane, all trigonometric functions, and when I talk about trigonometric functions, I mean the original 3 trigonometric functions are positive. So and the angles range from 0 to 90 included. So sorry. Also 0. So All of them are positive here. So I'm gonna denote that as A. In the second quadrant, so this is the first quadrant. Second quadrant, only sine is positive. And the angles range from 90 excluded. So that's the domain of the angles in the second quadrant. Anything greater than 90 and less than or equal to 180 degrees is in the second quadrant. So as I denoted here, all of them are positive here. So I'm going to put this as an S to denote that only sine is positive in the second quadrant. In the third quadrant, only tangent is positive. And the angles range from 180 to 270. 180 is excluded, but anything greater than 180 and less than or equal to 270 degrees is in the third quadrant. So and the last of the fourth quadrant, which is the fourth quadrant. So we can deductively say, because we can just use that method of deduction, since all of them are positive here, and we only have 3 trigonometric functions, we have already used up 2. So cosine is positive here, and the angle ranges from 270 degrees to 360 degrees. But 270 degrees is not included, so it's 270 less than theta, which is less than or equal to 360 degrees. Now, I'm also going to add something extra. That extra thing is, since we know if any angle, if we have, let's say, sine of 45, we know it's going to be a positive number. Cosine of 45, we know it's going to be a positive number. Tan of 45 is going to be a positive number. But if we have sine of, let's say, an angle greater than 90 degrees, like say 120, sine of 120 is positive. Anything in the second quadrant is positive, but cosine of 120 degrees is going to be negative because only sine is positive there. So leaving cosine and tangent negative. Only tangent is positive here. So any angle between 180 that's greater than 180 and less than or equal to 270 degrees is going to be positive for tan, but it's going to be negative for sine and cosine. And use that same logic for cosine as well. So sine 45 is going to give you a positive number. Cosine 45 is going to give you a positive number. Tangent of 45 is going to give you a positive number as well. But if you have sine of 120, you have a positive number as well. Cosine of 120, you have a negative number. Tangent, so on and so forth. And that's that for that. But the extra thing I want to add is, if we have an angle that's greater than 90, any angle that's greater than 90 degrees, that angle should be reduced. And in all the quadrants, I'm going to show you how all the angles are reduced. In the first quadrant, you don't reduce any angle. Theta or theta is just that. You don't reduce any angle. Here, so as I was denoting, all is positive here, only sine is positive here, only tan is positive here, only cosine is positive here. You can form an acronym. ACTS, which is act. So all cosine, tangent, sine. It's that simple. That's an abbreviation. Okay, now, how do we reduce angles or halide angles that are greater than 90 degrees? That's what we call them. We reduce them any time you see an angle that's greater than 90 degrees, always reduce it. In the second quadrant, so that therefore if the angle is greater than 90 and less than or equal to 180 degrees, we reduce the angle by saying 180 minus the angle. Well, I'm not going to circle it down. I'm going to put down brackets. Put sterics. Okay. So let's say you have cosine of 120. Cosine of 120, because I know it's going to be negative. Let's say cosine of 120. Cosine of 120. Because it's in the second quadrant, it's going to be negative. So it's going to be negative cosine of 120. So this is the angle, right? So in order to reduce the angle, because it's greater than 90 degrees, and it's in the second quadrant, so we use the formula. So it's 180 minus the angle. So cosine of 120 is equal to negative cosine 180 minus 120, 16. I didn't bring my calculator there. Anyway, but you can check. You'll see that it's the right answer. Okay, so that's that for the second quadrant. In the third quadrant, you reduce angles by saying the angle. So if it's like 210, so it's the angle minus 180. So let's say you have sine of 210 degrees. So sine of 210 is going to be negative sine of 210 minus 180 equal to negative sine of 30. So sine of 120 of 210 is equal to negative sine 30. Okay. In the fourth quadrant, you reduce angles by saying 360 minus the angle. So let's say you have tangent of let's say 330 tan because it's going to be negative in the fourth quadrant, so it's going to be negative 10 360 minus 330. So keep that in your head. Okay. Now I'm going to show you ACTS, just know that. I'm going to show you special angles. Special angles are angles you must know offhand. I mean, to be honest, I always tend to forget the special angles myself. But if I'm deriving them, I just know how to do it, and but if you just ask me, like in a normal day, let's say what's sine, I know what sine 45. Let's say what's cosine of 60. I probably will get it, but it's probably guesswork. I think it's root 3 divided by, it's either root 3 divided by 2 or half. So if it's not half, it's root 3 divided by 2. So it's like the inverse. I'm going to show you how I know. So the special angles are 0, 30, 45, 60, and 90. So we're going to associate numbers with them. So let's call this 0, 1. So let's define sine to be root n divided by 2. So n is the number, right, divided by 2. So sine of 0 will be root n, which is 0 divided by 2, 0. Sine of 30 will be root n, which is 1 divided by 2, that's a half. Sine of 45 is root n, which is root 2 divided by 2. Sine of 60 is, you see what I'm talking about? Sine of 60 is root 3 divided by 2. And sine of 90 is root 4 divided by 2, which is 2 divided by 2, which is just 1. How do we get cosine? Flip the whole thing. So you flip everything, therefore you start from 1. Root 3 sine 30 and cosine 30 is root 3 divided by 2. And sine 45 is equal to cosine 45, so that's root 2 divided by 2. Cosine 60 is half on cosine of 90. It's just 0. A tangent tan is equal to sine divided by cosine. Sine of 0 that's 0. Sine of sine of tan of 30 is half divided by root 3 divided by 2. That's probably 1 divided by root 3, I guess. So you have 1 divided by 1 half divided by this, which is times 2 by root 3. So that's 1 divided by root 3. You can write out root 3 divided by 3. So root this divided by this is just 1. This divided by this is like the inverse of this one, so it's root 3. And this divided by this is infinity. Okay, one footnote. I'm going to be using this idea that sine of perpendicular lines, angles between two, the equation of a line when the slope between two lines when I think you have seen this thing, like if you have two lines, L1 to be perpendicular to L2, therefore if the slope of L1 is M, therefore the slope of L2 S1, this is slope 1, S2 is equal to the negative inverse of the first slope. I'm going to show you how it's through this idea that we derived it actually. Okay, so I'm going to do some some rather interesting things. So let's do something like let's just like a normal random question. Let's say questions are these are rather simple questions actually. Let me see. Okay, so the first one, cosine. Sorry, my handwriting is becoming a little nasty, because it's too low. Sine of 330. First of all, 330 is in the fourth quadrant, so that therefore sine is going to be negative in the fourth quadrant. So it's going to be negative sine 360 minus the angle, that's 30, plus, well, it's not going to be plus because it's going to be negative here, so negative cosine of 180 minus 150, that's 30, minus tan of 210, so it's going to be positive because it's in the third quadrant. So minus tan of 210 minus 180, that's 30. Actually, it's actually a coincidence. I actually got the arguments to be 30. I actually didn't know it was going to be 30. Yeah. So minus tan. Is it 30? Yes, 30. So this is equal to, that's negative a half minus root 3 divided by 2 minus tan of 30, 1 divided by root 3. Now you can punch in your calculators to get this number, or you could just do LCM. Anyone works. The LCM will be 2 root 3, so if that's the LCM, 2 root 3, so that would be root 3 minus root 3 minus 3 minus 2. I hope you can see how I got these. So it's minus root 3, minus 3, minus 2. So minus 3, minus 2, that's minus 5. So minus 5 minus root 3 divided by 2 root 3, and then you can solve and get your answer. The other solution, so cosine of 315 minus that, minus that. So cosine of 315 is going to be positive because it's in the fourth quadrant. So 360 minus 315, so it's cosine of 45 minus, okay, look at this. So this is the argument and this is the function. So it's going to be cosine of 180. 180 is just, it's actually just 0. When I go further, I'm going to show you the graphs of cosine and sine. So it's going to be 180 minus 180. I say, is it 0? It's not actually 0. Oh, it's actually 1. My bad. So it's going to be 180 minus 180, that's 0. Cosine of 0 is 1. Sine of 1. What a sine is, it's going to be like a small number actually. Sine of 1 is going to be a very small number, but I don't have calculators, so I'm just going to write it explicitly. Minus sine 1 minus tan of cosine 90. I actually made this so it's going to be 0 because cosine of 90 is 0. So tan of 0 is 0. So it's going to be root 2 divided by 2 minus sine 1. If it was in radians, then I would just put this as 1, but it's not in radians, so it's going to just look like this. Okay. Okay, thank you. So I think we're not done actually, we're almost done. Something we really, just kidding that. I mean, I have to clean all of this actually. Take a last glimpse, and we have to talk about is the, what's it called? The inverse functions, or the reciprocal function actually. So we know, I think we all know this, sine of x is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. If sine is let's say sine of, let's say, x of an angle, sorry, let me put x. Let's say a right angle triangle is made of 3 sides. Sine of the angle is equal to y divided by z. Cosine of the angle, secant of the angle, y divided by sine. So it's the reciprocal. I almost made a mistake. I was about saying I'm going to talk about the what's it called, complementary functions. But the complementary functions are not the same thing as the reciprocal inverse functions. Okay, now I'll end today by talking about negative angles and negative numbers, negative values actually. But I won't talk about negative values today because it will burn most of our time. So I'll talk about negative angles. Okay. Normally, whenever we measure an angle, we normally measure it from the positive x-axis, anti-clockwise. So if there's something and it's like going this way, we measure it from here. And if it's here, we measure it from here. So we always measure from the positive x-axis anti-clockwise. That's this way. But if we're measuring something clockwise from the positive x-axis, we call those negative angles. Let's say, and I'm going to show you how to change negative angles to positive angles. Let's say something is pointing down this way, and we measure from the positive x-axis, and the angle is whatever that is, phi, whatever. Okay, let's call it phi. Let's say phi equal, well, let's not give a number. Let's call this other angle that makes the complete circle alpha. We know something. The angle of a complete revolution is 360 degrees. Therefore, we can deduce that phi, this is phi, plus alpha is equal to 360 degrees. Okay. One thing we need to know is if we measure this, because this is going to be negative of an angle. Let's say, okay, let me just give you an example to reduce the ambiguity. Let's call this -60. So because we are measuring clockwise from the x-axis, we call it -60. We know that this angle plus 60 equal to 360. So alpha plus the absolute value of the angle. So it's going to be plus absolute value of 60, which is 60, is equal to 360 degrees. Alpha is equal to 300 degrees. Okay, so we know some things. Let's say we want to do sine of -60 degrees. How do we do sine of -60 degrees? Okay. Look at something. If we're measuring, let's say we did not measure from here. Let's say we didn't measure from the, let's say we didn't measure clockwise. We say that the angle from here to here is 300 degrees. Therefore, if we're doing sine of, let me show you something interesting. If we're doing sine of phi. For example, let's do the general form first. Sine of phi, where phi is in the fourth quadrant. I'm sorry, sine of alpha, where alpha is in the fourth quadrant, where fourth quadrant. Therefore, sine of alpha is equal to what? Is equal to negative sine of 360 minus phi. I don't know if you understand. I mean, you should understand. So look at something interesting. Can you see how these two things are actually linked? Look, if we call this negative 60, for example. Let's say, okay, if this is negative 60, now we add these together, we get 360, therefore phi becomes 300. If we use that formula, we say that sine of phi is equal to negative sine of 360 minus phi, where phi is 300, that's 60 degrees. That means we can write this negative angle as sine. Therefore, we can say that, just a duster, we can say certain things. We can say, since we're measuring the same location, let's say it's a vector location somewhere here, and we're drawing from the origin. So this is the origin, the x, y, negative 1, negative x. And this is negative 60. Therefore, we can say that sine of negative 60 is equal to negative sine of 60 degrees. I don't know if you understand. It's actually self-explanatory. I think it's really easy to grasp. So let's say we wanted to do sine of negative 30 or something. You'll see how, let's say, sine, let's say we drew something like this. If I told you, find the positive angle of this angle, which is said to be negative, we say that the positive angle is given by alpha, which is 360, minus 30. Therefore, phi is equal to, alpha is equal to 330 degrees. Therefore, we know something. We know that 330 degrees is equal to negative 30 degrees. So let's say we wanted to put a function in front of it. If we wanted to put like tan of negative 30, we can do it in in two ways. We can do it first by saying, since alpha is equal to phi, but just the positive version of phi, we say, we return this to a positive angle and say tan of negative 30 is equal to tan of 330 degrees. Or if we don't want to do a step, because we get the same thing, tan of negative 30 degrees is equal to negative tan of 30 degrees. Why? Because if we convert this, tan of 330, it's in the fourth quadrant here, isn't it? It's in the fourth quadrant, so we reduce angles, and tan is negative in the fourth quadrant. So tan of 330 degrees equal to negative, because it's the fourth quadrant. So it's going to be negative tan of 360 minus 330. That's 30. So we know that we can derive the following axioms. Okay. Before I list out the following axioms, I need to do on what I've done for sine, I've done for